Hey guys, welcome to the channel. Today's video is going to help us have a better understanding of the benefits and potential downfalls of the most common item you're going to find on your budget-friendly import lathe, and that is the 3-jaw scroll chuck. So a few updates before we get started. We got the block back for the Chrysler, so that means you all know what the next few weeks and months of content are going to be. The Galaxy got back burned even before the Chrysler, and all the progress we have made is starting to kind of flash rust away. But that's definitely going to fall into this year's winter project, even though it was last year's winter project. I'm happy to announce I finally got a semi-professional level camera that I really need to take the time to figure out all the functions and features on, because I'm used to GoPros where you just set the resolution and frame rate, forget about it, aim it, push the record button, and that's about it. And that leads us back to the point of today's video. I bought a budget-friendly lathe mill combo off of the internet of all places, something you might have done. And we don't regret that at all, do we? So as to not contribute to the incomprehensible amount of unwatchable and unwatched videos uploaded to YouTube every 24 hours, let's get to the point. Something I somewhat successfully made the other day. As it turns out, entering this new metal turning adventure with a humble attitude and an alarmingly selective OCD level demand of hyperfixation, perfection, and task-based dopamine reward, my own standards were significant. So whether you're a seasoned machinist or a complete novice lathe operator such as myself, but you have a cheap import lathe from either China or Taiwan, you are likely to have with it a low to mid level grade 3-jaw scroll chuck attached to your spindle, and therefore a convenient way to quickly clamp and center a workpiece for turning operations, whether it be round stock, square bar, or even odd shaped pieces, depending on your setup and if you have a 3-jaw or a full 4-jaw scroll chuck. Does your chuck do this? Congratulations, you have a scroll chuck, and you probably already knew that. Now, I'm not making a case against them. They've been around for 180 years. But if you care at all about accuracy while being able to remove a workpiece and then reinstall it, or installing something that's already known to be perfectly round, these style chucks will have you turning in circles. They do, of course, make significantly higher quality precision type scroll chucks that are generally priced out of reach for us peons. But today we're going to do my best job of illustrating the built-in intolerance in one of these and why grinding your jaws will not ever be able to fix that. So the root of that problem exists in the scroll itself. So for now, forget about this brand and that brand, and we'll focus on the one in front of us, which came off of a Grizzly G9729. This is a 5-inch 3-jaw scroll chuck. It has 3 mounting bolts. You can see it's fully assembled, and in a little jig I made up to help illustrate the aforementioned problem, hopefully your eyes and brain can make sense of what's going on here, but I'll do my best in the meantime to keep you entertained. First, you need to understand that this chuck is normally bolted to a spindle on your lathe. Now, assuming your lathe is in good condition, your spindle itself should have minimal to no run out in any direction. Second, your spindle has a fixed axis, which in an ideal environment, once this chuck is installed and centered itself, it should be able to center any workpiece being affixed to it to that axis. Third, you need to understand that in this test we're dealing with no specific diameter. These pieces and positions are all random and or coincidental, but repeatable. And fourth, what we are measuring is the consistency of concentricity that the scroll itself controls on these jaws as they move in and out. And fifth, you'll notice there is no preload on these jaws. They are able to move about freely in their channels, so let's eliminate some of that preload for this purpose. Go ahead and use some rubber bands. So as we go through this, you will see that you can achieve these results without using a test piece. So we're going to run this a few different ways. The first thing we're going to do is we have a perfectly burnished round wrist pin for an engine. We're going to gently clamp it in the jaws and then set up all of our dials to 0. So just a very slight preload. Our jaws are preloaded. We have a test piece clamped in and all of our dials are at 0. So let's go ahead and remove the workpiece. Now I'll roll back a little and let's roll back to our 0. We'll use this gauge. We'll set this gauge to 0 and see what happens to those two. All right, good. We are mostly on 0. These may drift a tenth or so, but as you can see, we're mostly on 0. So what has that told us so far? Nothing really. We have 3 jaws that are fixed on a 2-point plane, 3 points of contact, a known quantity, and a variable that you can't actually see, that being the radial angle at any given point on the scroll. Think of an Archimedean spiral. If this piece is not machined absolutely perfect alongside its corresponding counterparts, you certainly would know by the price. These dials are on 0 because I placed them there. But now we have a starting point. Regardless of any existing intolerance, we've just calibrated these to this specific point orbiting our known quantity. So let's simply grab another known quantity, a perfectly round piece of aluminum, and throw it in the chuck. But before we do that, let's run a full 100 thou sweep and stop at random points to see if we can see any jaws chasing or lagging behind. Let's go ahead and roll this inwards. Let's stop at the 70. We're going to use this gauge as our primary gauge for now. So 70, we stopped here at 70. The blue jaw, we're at 70. Silver jaw, we're at 70. Let's roll to the 50. So we're still pretty even right now. All right. So we're right at the 50. We're right at the 50. And we've just started to drift. We're about halfway to 3/10 off the 50, between 50 and 51 on our silver jaw. So let's roll back up to 30. Again, using this gauge as the primary gauge. 30 and 30, almost dead on. So now we'll roll it back to 0. Now remember, we're 100 thou closer. These jaws are on a different part of the scroll. So we're still at 0, 0, 0. So between that particular dimension, that 100 thou drift, we seem to be, for instructional purposes, it's perfect, right? Let's keep going. Again, this is reflecting any random diameter workpiece you may put in here or remove and reinstall. So we'll do 70 again. Ah, something's different. We're not at 70 on the blue jaw, we're at 70 on the red jaw, but the blue jaw, we're at 69. The silver jaw is trending kind of right in the middle, between 69 and 70. Let's go to 50. Back up a little. Overshot it. Alright, so we're right at 50 on this red jaw. We're about between 49 and 50, closer to 50 on the blue jaw, and about the same on the silver jaw. About dead on the silver jaw. So we had a variance when we were at the 70 of about 1 thou to 1/2 thou. Let's roll this to 30. Overshot it a little bit. Let me back up. Pretty dead on. Pretty dead on. So let's roll it back up to the 0. And we're pretty dead on. All right, let's go ahead and install this piece. All right, so where did that land? So we're on the 34. We're between 33 and 34 on the blue, and we're a few tenths off of the 34 on the silver. So far it's looking like this chuck is fairly accurate. So let's go ahead and remove this again, and we will reinstall our test piece. Now you will see with all of the finagling around, everything still landed right back on 0. So that tells us our indicators at least stayed true to their original positions while exposing an intolerance somewhere along the scroll wheel, along the range of its travel. Had your already round workpiece met its clamping force at one of those particular points, it would dial out of round once affixed. Our aluminum test piece is an example of that. Once we're done here, I'm going to install this chuck back on the spindle now that it's been cleaned and serviced. I'm going to ensure it's trued out to the spindle, and I'm going to demonstrate this in practice. But since our indicators could have been set to 0 within an intolerant section of the scroll, again, it just could be random, let's pick another random spot to see if we can define it further. Understand there's a large range of motion available on this 5-inch chuck, so without a ton of resetting gauge positions, we're just going to operate within this inch or so. Let's roll down to here. So we'll roll down to here. It's a little bit closer. Alright, so everything's recalibrated to this particular dimension. Doesn't really matter. Let's go ahead and roll this down to 50. Alright, so using this gauge as the primary gauge, the set gauge, you can see we are closer to 49 on the blue jaw and almost dead on 49 on the silver jaw. So we're about 1/1000th off on our blue jaw and 1/1000th off on our silver jaw. Using this red jaw as the set dial indicator, this is illustrating if you have a known round workpiece and you are affixing it in your chuck and it happens to meet its clamping force at this particular dimension, it's going to dial out of true once it's affixed. And just to double check, let's roll back to 0 and make sure everything's still on 0. We're going to overshoot and drive in. And this one's a little off, just a hair. dealing with, this is my older one, dealing with Harbor Freight. That's good. Don't worry, I'm not cheating. So we're back at 0, and this one's a little old. Now let's do something different. Changing nothing. Let's set 50 on this dial indicator. Overshot it just a little bit. Overshot it just a hair. And now we're at 51 thou on this, and pretty much near enough to make no difference. Maybe 2-3 tenths off of 50 on the silver jaw. So now this one's trending off. So let's roll this back to 0 again, just to make sure everything's still where it's supposed to be. Oh. Shoot, roll in. 0, 0, 0. Now let's set 50 on this dial indicator. Get that out of the way. And I bumped it. Dang it. So 50, 50, 51. So while it seems like this is making the case for this jaw in particular being 1/1000th shorter than the other two, at this position we aren't measuring contact points. We're measuring travel. We set our indicators to 0 on all 3 positions, and they always returned to 0. Calibrating our indicators to 0 is referencing all things being equal at that start or at that point. It's the travel that's the variance here. So let's just do it one more time. Let's roll this, let's go even tighter. We'll go like right here. Let's make this our new 0. Oops. We'll make this our new 0. We'll roll off and roll towards 0. Make sure we're all still there, all nice and happy. Boom. We're all still at 0. All right, let's roll to the 50 again. Again, we've traveled about 200ths further in, according to the big end of the dial indicator. We were at the 700th mark of the travel on the gauges. Now we're down to 5. So we'll roll this even, we'll get even tighter. We'll roll it into 50 again, using this as the primary. And you can see, yep, about almost 51 and dead on 51. So we'll roll back to 0 and use this as the set indicator, then this is the set indicator. So we'll roll back to 0, make sure we're all still there. Looks good to me. We'll set 50 on this one. And annoyingly, we're almost perfectly on 50 here. And we're at about 51 on this one. That one, okay, that one's off just a hair. So 50, just about dead on. We're closer to 49 actually on here. It's a few tenths off 49. And this one, we're about a few tenths off of 50. And that's again using this as the set indicator. Roll back to 0 just for the heck of it. 0, 0, 0. Now let's use this as the set indicator. We'll roll to 50. Closer to 49. Closer to 49. So we're losing that consistency in the variance. Now we're trailing behind over here as well on both of these. Now you see a lot of videos on YouTube on how to true up a 3-jaw scroll chuck or 4-jaw scroll chuck, and a lot of them talk about grinding or even using a boring bar to even the jaws out. Now, this practice is completely necessary if your jaws are clearly worn out to the point of a noticeable reduction in mating surface on your clamping point. That's sometimes called bell end, but it's really just your jaws being splayed outwards after the years of applied force against them. Now, while that process will certainly straighten up your jaws, for an intolerance as small as this one, to go through the effort to buy a tool post grinder or a drill setup, which wouldn't be a bad idea to have anyway, that's not going to change a thing. So that process has to be done with these jaws clamped inwards against something. They need to be pushed up against something. Some people, they cut grooves in here and put a ring, or they install bolts or something and put a ring. But all you're going to manage to do is consider your chuck is perfectly trued up against the spindle. Once you start grinding on these jaws, yes, you might be flattening them out, but all you're doing is calibrating these jaws to a perfect axis at a completely random diameter. Let's say you manage to rig something up where you can grind these jaws out and you can take this piece in and out as many times as you want, and it's perfectly zero because you've met all the intolerances together at a point and ground them away. But all it's going to be good for is turning this particular diameter. It's really a waste of time. So how do you make this to perfectly zero in on something that's already round, or to be able to pull out a workpiece and put it back in and it still be perfectly true? You replace this with an independently adjustable 4-jaw chuck. Now, these being around for 180 plus years, they have a place in a machine shop. They're very good for single operation processes. As you put something in there, you turn it, index it, whatever you're going to do, and part it off, and you're done. And again, the problems arise when you remove something that's already been turned and try to put it back in. Even if you mark exactly where it was, a lot of times you just can't get it dialed back in, and it's a very frustrating experience. But to put this into practice, let's go ahead and reinstall this chuck on the lathe so we can reiterate this process in a practicum environment, and you can see visually at another angle what I'm talking about.